Okay, hello students. In the last class, I have already discussed the flaws related to Rutherford's atomic model. We have already discussed that it could not explain the stability of an atom. Okay, then came Bohr Baba, who gave his own model, Niels Bohr, which is known as Bohr's atomic model. Now, according to him, electrons revolve in special orbits. Okay, they do not, according to Rutherford's model, electrons they revolve in circular orbits, in any ordinary circular orbit, he said. But he did not show in what way, what is the procedure in which the electrons are distributed in the orbits. Now, this person came up with his own atomic model, which we have been using till date. Uh, Electrons revolve in special orbits, and these special orbits were termed as stationary orbits. Okay. Now, stationary orbits means stationary. Stationary means it is not moving. Orbits are not moving. So, stationary, in what sense this is saying stationary? Means it does not radiate energy. It does not radiate energy. Now, what does this mean? This was the flaw, no, which was incorporated in Rutherford's atomic model. Remember? So you have to remember. So this is our nucleus, which is comprised of protons and which consists of protons and neutrons. And according to Bohr, electrons revolve in circular orbits along with elliptical orbits. He introduced the concept of elliptical orbits. Elliptical orbits. Ellipse is also a conic. Okay, which is some sort of circular. You can imagine an egg-like structure of this type, this egg-like structure of this type or this type, elliptical orbits. So electrons they revolve in elliptical orbits, which are called stationary orbits. Now, suppose I have electron here. You people know actually, no? So these electrons they revolve in stationary orbits. These orbits are called stationary orbits. This orbit was called K orbit, L orbit, M, K, L, M, N. You all remember this, isn't it? Now what happens is, these orbits, they do not radiate energy. As they do not radiate, stationary means they are not radiating energy. As a result of which, these electrons will not lose energy. If these electrons do not lose energy, they will not come to the nucleus. If they don't come to the nucleus, our problem is solved. This atom becomes stable. Atom is stable. That is what is there in the nature. Atoms are stable, that is why we are stable, isn't it? So the concept of stationary orbits was introduced by Bohr's atomic model, and it beautifully explained the stability of an atom. Okay, so basically the electrons are arranged in K, L, M, N, so on and so forth cells. So where the electrons follow this formula 2n square. In the first cell you have to put n is equal to 1. So 2 into 1 square, that is 2 electrons. In the first cell we can have only 2 electrons. In the second cell we can have 2 into 2 square, that is 8 electrons. So on and so forth. It goes like this. Are you understanding? So the distribution of electrons in different orbits. Okay. The distribution of electrons in different orbits was also, the method of distribution was also given by Bohr. Okay. So as a result of which, the flaw incorporated in Rutherford's atomic model was overcome, and then we are also happy, everyone is happy if an atom becomes stable, isn't it? So other things, I have already taught you how electrons are arranged in different cells. The method in which electrons are arranged in different cells is called electronic configuration, distribution of electrons. That I have already said how to do. And valency, you know, combining capacity. So in order to attain stability, how many electrons they want to lose, gain or share so as to attain stability, that gives you the valency of an element, that you all know. Now a very important topic is left in this chapter that I will discuss, okay, and then we'll wrap up the chapter. The important topic is isotopes and isobars. Isotopes and isobars. Now these are very important. Iso means same. So iso means same. So something has to be same. Isotope means atoms of same element having same atomic number but different mass number. What does this mean? You people remember, no? When you write the symbol of any element, this is known as mass number and this is known as atomic number. A is your mass number. So A is your mass number. So mass number is number of protons plus number of neutrons. This I had already taught. And atomic number Z is your atomic number. So atomic number means number of protons which is equal to number of electrons. So number of protons in an atom is exactly equal to the number of electrons. That is why we say that an atom is electrically neutral. These things I have already mentioned it clearly in the preceding chapters. Okay. Now, isotope means atoms of same element having same atomic number but different mass number. Now see. So for example, I take hydrogen. 1, 1, 1. So these are atoms of same element. These are atoms of same element. You can say hydrogen, hydrogen, hydrogen. They are same element. They are having the same atomic number 1, but they are having different mass numbers 1, 2, and 3. So these are known as isotopes of hydrogen. Isotopes of hydrogen, and it exists in nature. Okay, isotopes of hydrogen. So there are other isotopes also we'll discuss. So as you can see, this is having mass number 1, this is having mass number 2, and this is having mass number 3. So this is called protium, this is called deuterium, and this is called tritium. Okay, so these are the names of the isotopes of different isotopes of hydrogen. Now let me talk about another isotope, which is isotope of chlorine. Okay, so isotope of chlorine, we have isotope chlorine 17, atomic number 17, and mass number 35 and 37. So these are isotopes of chlorine, atoms of same element chlorine, and having same atomic number but different mass number. Now this exists in the nature in the ratio 3:1. So that means 75% of chlorine 35 is present in the nature, and 25% of chlorine 37 is present in nature. So the mass of chlorine is considered to is taken as the average of these two combinations. How do we take the average? So average is taken by 35 into 75 by 100 plus 37 into 25 by 100. This will give you 35.5. So this is the celebrated mass of chlorine atom. That is what you take, 35.5. Okay, this is the mass of a chlorine atom, you can say. Okay, and this is the this is what you use when you are solving the problems also. So why we are using 75 and 25 is, in nature it exists in the ratio 3:1. So this is 75% and this is 25%. So if you take the average of this, you will get 35.5. So basically isotopes are atoms of same element having same atomic number but different mass number. This thing you have to understand. Okay, now hope this is clear. Now let us quickly discuss about isobars. Okay, now iso means again same. Iso means same, but what is same here? Here in isobars, what we introduce is atoms of different elements. Okay, atoms of different elements having same mass number but different atomic numbers. For example, let me take calcium and argon. Okay, calcium 20, argon 80, mass number 40, mass number 40. Now it is clear from the example. Atoms of different elements, different, this is calcium, this is argon, these are two different elements having same mass number. This is having mass number 40, this is also having mass number 40, but different atomic numbers. This is having atomic number 20 and this is having atomic number 80. These type of elements are called isobars. Okay, so isotopes and isobars are very, very important from an examination point of view, and you have to know some examples of isotopes and isobars, and you have to understand very, very clearly what isotopes and isobars are. Don't ever mug up, just understand. If you don't understand anything, if you have any problems in any concept, you can always ask me. Okay, so I think this is the end of the chapter. I didn't discuss about valency and electronic configuration in this chapter because you all already know it, and I have already discussed it in the previous sections. Okay, so we'll stop here. Thank you so much.